Let's try that again. Good morning, everybody, and welcome to IGTV. We have William H. Murray on with us from Connecticut, and Bill, you're enduring through Hurricane Irene. You're going to take us through AES, and is it broken? Go ahead.
Okay, that's the headline. What does it mean, and should you care? In general, what does it mean to say that a cryptographic algorithm is broken? Does it mean that the cost of recovering the clear text without benefit of the key has suddenly fallen to zero? Well, that would qualify, but no, crypto does not fail that way. Does it mean that the cost has fallen to be equal to that of encrypting with the key? Again, clearly that would qualify, but no, it doesn't mean that either. Well, how about the cost has fallen to be equal to the value of the data? Or the time required to recover the clear text has fallen to less than the life of the data? Well, if either of those had happened, even I might agree that the algorithm was broken. However, neither of those has happened either. For a standard algorithm, one might argue that an algorithm was broken if the cost of attack was lower than that claimed by the standard. For example, the data encryption standard, the claim was that the cheapest attack was an exhaustive attack against the key. On average, half the time required to try all possible keys. By that standard, the DES is still not broken, lo these 35 years later. It is true that using a bot farm, one can do a brute force attack in days. However, for many applications, the life and value of the message are such that no one would spend even that much. For RSA, the claim is that the cheapest attack is a function of the cost to find the factors of the product of two large primes. While finding the product of two primes is trivial, finding those two numbers, knowing only the product, is a problem that has challenged mathematicians for ages. By the time required to try all the DES keys falls as the power of while the time required to try all DES keys falls as the power of the computers goes up, we always know what that is. Similarly, the time required to find the factors of the product of two large primes goes down as computers become more powerful. In that case, we simply increase the size of the numbers. It might even get cheaper as mathematicians get smarter, but it's unlikely to drop suddenly, and it's unlikely to drop without people knowing about it. AES is not a standard in the same sense as the DES or RSA. No claim is made for its strength. Rather, it is a standard because an authority, NIST, says that it is. Its strength is what it is. We know that the most expensive attack is a brute force attack, but not only has no one ever asserted that there is not a cheaper attack, it has been demonstrated, at least mathematically, that there are cheaper attacks. Said another way, by definition, one cannot ever say that AES is broken. The best one can say is, I can find a key this fast. While some claim that broken in cryptography is defined as any attack that's faster than brute force, that simply justifies the claim of the headline. It is not a definition that is meaningful in any sense that a layman or even a security professional can understand or use. By one estimate, the time to brute force a 256-bit AES key is 5 times 10 to the 51st power years. What the authors of the paper claim is that they can do it in a mere 10 to the 51 power years without the 5. While that may be an interesting, even dramatic improvement, certainly worthy of a paper, even a headline, it does not justify the use of the word broken in any practical sense. Whatever the authors and the headline writers might claim, it is an irresponsible use of language. These authors have simply established the new standard cost of attack for the AES. This is a mathematical assertion that defies any other demonstration. Such an attack, begun at the Big Bang, would not have completed yet. We call that strong enough for security work. Now, I like cryptographers. Most of them are very nice people. However, like many such guilds, including security professionals, they have their own special jargon. I appreciate the fact that they do all of these heady calculations for me. However, their security advice is on a par with their medical and their legal advice. Creating a cipher that you yourself cannot break is relatively easy. All the work is in learning enough about it to be able to predict how much work it would take a body of experts to break it. We call that effort standardization. And that's what's really going on here. It's not breaking in any meaningful sense. Now, does all of this mean that our cryptography is safe? That even nation states cannot read our encrypted data? Not. It has always been my assumption that nation states in general, and the United States and Russia in particular, can read any traffic that they wish. I am reminded of three colleagues, Phil Zimmerman, who wrote PGP and called it pretty good, Adi Shamir, one of the authors of RSA, who wrote, "People do not break crypto, they bypass it." And Brian Snow, who spent a career breaking codes at NSA and who said, "At NSA, we spend as much time and resource on systems as on codes and ciphers." Algorithms are the strong part of our systems, orders of magnitude stronger than we need them to be. People are the weak point, and implementations are in the middle. While it might take the life of the universe to try all possible keys, one might brute force the 8-character lock word used to hide it in a day. Failing that, attackers might bug your systems, suborn your associates, or break your fingers, one after another. Life would be wonderful if our security was determined by the height of our walls rather than by the guards at our gates, by the strongest link in our chain rather than the weakest. On the other hand, then we might not need security professionals or pay them the big bucks. God willing, Connecticut Light and Power doing its job. I'll see you next week.
All right, Bill. Very, very, very astute observations there. Certainly do appreciate that. All right. And I think you're absolutely right about that. The encryption, it works for what it's needed for right now. And you're right. If it's a nation state, they're going to know anyway.
Right.
Because they're just going to put a pound after it. And, nothing's impossible. Once you decide to put that much effort into it. All right. I hope the electric returns up there shortly, and you folks over in Connecticut are enduring, hopefully, with some nice surroundings, as I see your host has provided you there. Looks like an absolutely beautiful place behind you. All right. Stay warm, stay safe, and we'll see you next week.
Very good. Thanks.
All right. Take care now. All right. So